Okay, hello everybody. We are now going to talk about section 1.5. So this is about transformations. There's the link to the section there. All right, so transformations just refers to ways that you can change around the formula and how changing the formula will change the graph of a particular function. So the first thing you can do is you can do vertical shifts or horizontal shifts. So for example, a vertical shift that comes from adding a value k on the end of the formula here. And so the value of k is going to end up describing how far up or down you move the graph. So for instance, we'll talk about a parent function here. There's all sorts of parent functions you can have. So you can have like y equals x squared, y equals root x, y equals the absolute value of x. You could have just y equals x, that would be a line. You could have y equals 1 over x. You could have y equals x cubed. There's lots of different formulas that you could have that are considered parent functions. And these are basically your just most basic generic kinds of functions that you can have. You could have a squared graph, you could have a square root curve, you could have a v, which is what absolute value looks like. Y equals x is just going to be a line. 1 over x gives you this kind of funky curve called a hyperbola. And then the x cubed graph is a S curve, is kind of what that looks like. And so with each of these parent functions, you can basically transform them in different ways. So for instance, if I told you that the parent was x squared, then if I gave you the graph or the equation y equals x squared plus 4, what that does is it'll just shift the graph up 4 is what it will do, because what the plus 4 in the formula is doing is this plus 4 is moving the graph up 4 spots. And that's applied to the y because it's applied to the entire function. The reason it's a vertical shift, the y is vertical, y moves up and down. So if you're adding something to the whole function y, that means you're moving all the y values up by 4. If, on the other hand, you have something like y equals x squared minus 3, that would mean that you would shift the parent function down 3. And the reason it's down is because this time around we are subtracting, and we have moved the graph down 3. We're subtracting 3 from every y value. Let me show you with the graphing calculator kind of what this implies. So let's see here. Okay, here we go. So if we've got ourselves our graphing calculator here, what you can do after you turn it on, you can go to the y equals menu. Just clear out anything that's there. So if we want x squared as our frame of reference, you hit this button right here next to alpha. There's your x. Your squared key is this one right here. So there's x squared. And then if you push the graph button, you'll get a very lovely parabola. Let's hit zoom. And then if we arrow down to option 6, we can choose zoom standard and we press enter. And that'll just make it look a little less stretched out. But you got yourself kind of a garden variety parabola right there. That's the parent function. And then if we want to see how we can transform it, if we do x squared plus 4, and type that in, go ahead and push enter there, and we want to graph it. And then what you'll see is we now have a second parabola, and lo and behold, it is 4 notches up above where the other one was, so that you can kind of see this movement in action. And then like if you go to y equals, you could change this to -3 was the other one that we did. So you can do -3 right here. Go ahead and graph that. And then there's the first parabola. And then there's the next parabola, which is down lower than the original one. It's 3 spots down from where we began. So that is vertical shifts. So how you can move the graphs up and down. So then if we look at f of x minus h, so when you're inside the parentheses here, that means you're going to be doing things to the x direction. It's going to be horizontal shifts, so it's going to move things in the x direction. So what that'll mean is if you were to subtract 2, it would actually go 2 to the right. If h is positive, the graph will shift right. If h is negative, it will shift left. So this is maybe a little counterintuitive, but like, let's say my parent function was the square root of x, let's just say. So if I were to do y equals the square root of x minus 2, you notice this already has a minus in its formula to begin with. So this may be a little bit counterintuitive, but if it's -2 like that, it's actually going to move you to the right by 2, which is a little counterintuitive, but that's what would end up happening with a graph like that. If you had, on the other hand, the square root of x plus 1, that would actually send you to the left 1. And again, it's kind of backwards from what you would expect. Plus 1, you might think would go right because that's where the positives are, but it's actually going to do the opposite of that. If you do plus 1, it's actually going to shift you to the left. And the formula puts this extra minus sign in there to account for that. But like if this was a negative, they're basically saying x plus 1 is x minus -1. And then this value that's subtracted, that tells you how far left or right you would go, because you're actually going based off of the value that's subtracted here. So we could do something similar with the graphing calculator here. So if we go to our y equals menu, we can clear out each of these. And clear those out there. So what we can do is if we do second x squared, that's where the square root function lives. You can do the square root of x. And then alongside it, let's graph the square root of x minus 2. And we'll see what that one looks like. So if we go ahead and push graph on this thing, there's a square root curve. And then the second one it draws is to the right by 2 spots. If I go back in and make this +1, and then graph that. So there's the original one at 0. The next one is 1 spot over to the left. So let's see here. What do we have next? Come on. So then they say, given f of x equals the absolute value of x, sketch the graph of h of x where it's -2 and +4. So what is this going to do? Well, if you're subtracting 2, that is going to move you right 2. It's going to be kind of the opposite of what you might expect. Even though it's minus, it's going to send you to the right instead of to the left. This right here is a +4, which is applied to the whole function. That's going to be up 4. So if we're going to sketch what this graph looks like, and you can use a calculator to help you do this, but if we start with the parent function, the parent function is x, the absolute value of x. So if you take the absolute value of 1, you get 1. The absolute value of -1 is also 1. And if you take the absolute value of 2, that gives you 2. If you take the absolute value of -2, that is also 2. So the absolute value graph is just a V shape. Mine's a little wobbly here. Let's try that again. It's probably about as good as I can make it. But anyway, so that is the parent function right there. So this right here is y equals absolute value of x. So what we would do is we would move this graph. We would need to move it up 4 spots. And then right 2 spots. So if we go up 4, and then if we go right 2, we're going to end up with a new graph. It's going to start right there. And then if we go over 1, it'll go up 1. If we go over 2, it'll go up 2. And we would end up with a graph that will look something like this. So that would be the child, if you will. If the one's the parent function, this would be the child function. So there you have it. This one is y equals the absolute value of x minus 2 plus 4. You can have the graphing calculator help you with that. So if we go here, let's clear this out. I can show you how to find absolute value on this thing. So if you go to the math button right there and push math, and let's see, let's arrow over to the num menu where you see the function abs, that's absolute value. So if you push enter, it'll pick that, and you see there it's got the absolute value lines, how you'd write it. You put X in there. That'll be the parent function. We can graph that just by itself. There, as promised, there's the V-shaped graph that is absolute value in all its glory. If you then go to Y equals, and then again, we want the math menu. So you push math, go over to the number submenu and just pick the very first option there for abs. What was it? It was X minus 2 and then a plus 4 outside, if I remember right. So X minus 2. And then we're going to want to arrow over so we're not inside the absolute value lines anymore. And then if you do plus 4 and graph that. So there's another one that is 4 up and 2 to the right from where we were originally. So that is the child function alongside its parent function. What's up? Yeah, mine, it's the mirror image, so it's, yeah. Let's see here.